Welcome everyone. Today we'll be presenting our project, the Nexus Green Protocol. Cryptocurrency has transformed how we think about finance and decentralization, but it comes with a major downside, its environmental cost. Our project focuses on solving that problem in a practical and scalable way without disrupting the systems that people already rely on, such as Bitcoin. The Nexus Green Protocol is an innovative software solution designed to significantly reduce the energy consumption associated with proof of work blockchains. To put this into perspective, Bitcoin alone consumes hundreds of terawatt hours of electricity per year, more than some countries, making it a major contributor to carbon emissions. The challenge is that Bitcoin's core system is extremely difficult to change. It's decentralized, widely adopted, and any major modification would face strong resistance from the community. So instead of trying to fix Bitcoin internally, we take a different approach. We introduce a middleware layer that connects Bitcoin to a proof of stake sidechain, a system that requires drastically less energy. This allows us to preserve Bitcoin security and infrastructure while enabling transactions to be processed in a far more efficient and sustainable way. Our solution is built on a simple but powerful idea. Don't change Bitcoin, build around it. We create a sustainability bridge that links Bitcoin to a proof of stake layer, allowing transactions to be settled using a fraction of the energy. Instead of forcing users to switch systems, we give them a choice. They can opt for a greener transaction while still operating within the Bitcoin ecosystem. This is important because adoption is driven by convenience and incentives, not just ideology. As more users choose the low energy option, market dynamics begin to shift. Demand gradually moves away from energy intensive proof of work processes and towards sustainable alternatives. Over time, this creates a realistic pathway to reducing the environmental impact of crypto without needing to overhaul the entire system.
So we have three research questions and they all come from gaps in assignment 2. The first one is about compatibility. Bitcoin uses 204.4 terawatt hours per year. That's 34 million times more energy per transaction than Algorand. But you can't change Bitcoin from inside. The governance won't allow it. So we're asking to see if we can bridge it to a POS sidechain using its own scripting tools without touching the core code. The second question is about incentives. Assignment 2 showed that better mining hardware doesn't actually reduce energy use because of its Gibbon paradox. More efficiency just brings more miners. So we need a token model that makes people want to switch BTC for value, NXS for staking, fees under a tenth of a cent. And question 3 is about environmental verification. There is no way right now to verify if a crypto is actually green at the transaction level. Anyone can claim it. So, this one is about putting energy data on chain so anyone can audit it themselves.
Now I will walk you through the high-level architecture and system flow of an Nexus. This diagram shows how the mining components interact and how the transaction moves through the system from the user to the Bitcoin network and back. The Nexus system works by creating a bridge between Bitcoin and a more efficient sidechain. First, users lock their Bitcoin in the bridge and receive NBTS, which represents their Bitcoin on the sidechain. They can then use NBTS for fast and low-cost transactions, which are processed using proof-of-stake system instead of energy-intensive mining. When they are done, they can convert back by burning NBTS and their original Bitcoin is released. Each component has a clear role. Bitcoin provides security, the bridge ensures safe transfer, and the sidechain enables speed, and sustainability. For implementation, we selected technologies that balance performances, security, and sustainability. Substrate is used for sidechain because it supports proof of stake, which is much more energy efficient than traditional mining. For Bitcoin integration, we rely on Bitcoin and Trust Bitcoin since they are secure and widely used. Rust is chosen for validation clients because it is fast and minimizes resource usage, which helps reduce energy consumption. For the user interface, React Native allows us to build cross-platform applications efficiently, avoiding duplicated development effort. PostgreSQL ensures reliable and efficient data storage, while Grafana allows us to monitor system performance and energy usage. Overall, these choices reflect a deliberate focus on building a system that is not only secure and scalable, but also environmentally sustainable.
For outcome, every transaction on Nexus saves about 1,129 kilowatt hours. That's a 99.97 reduction. At just 10% adoption, we're looking at 113 terawatt hours saved per year and 53 million tons of CO2 avoided. Fees drop from $2 to $50 down to under tenths of a cent, and miners can become validators instead of being left out. On the risk side, yes, it's more centralized, but we require 100 plus validators with rotation and slashing. Bridges have been hacked before, so there is audit and insurance fund. And even if cheaper fees cause more volume, Nexus is still 99.97% more efficient. The math holds up.